background because I've done that before. All right, so guys, what I would like you to do is go to the blank side of your notes. Okay? Go to the blank side of your notes. Sierra, over there on the computer, will you want to be my typer this hour for decimals? Okay, will you open up here? I'll open this up. I'll tell you when to type, okay? Are you guys into decimals in your Chromebooks right now? Okay, if you're not, go ahead and log in and get there. Okay. Thank you. And I'll tell you when, okay?
Okay.
All right. So make sure you're here. How many of you guys use this tool to help you out with the last assignment? Pretty reliable, isn't it? Okay. Really helps you verify exactly what you're doing. So guys, this idea that we're working on right now are parabolas, or what we call quadratics. And this is formed by the general function y equals, what am I going to put in here, gang? Y equals what?
X squared.
X squared, good. Okay. And I'm going to go make this a little bit easier to see for you. Talk projector mode. Now guys, here's what I want to talk about. Sierra, you ready to type?
Mm-hmm.
Sierra, do me a favor and get me into field 2 right here. And type in something like y equals x squared minus 3.
Why did it just do that?
Back up a second. You have a subscript for some reason. Go ahead and back up on that. And hit 8 of the second here. Got it? Okay, so guys, based on last section right here, we had the general form of a parabola, y equals x squared, in red here, right? You guys agree with that?
Yeah.
So this minus 3, what was the effect of a minus 3 on your original function? What happened here? Move down 3 units, okay? I'm going to get rid of this one up here, and this is what we're really going to talk about, guys. If you notice on decimals right here, how many points do they highlight on my graph right here? They highlighted 3 of them. Okay, how many points are on the x-axis?
1, 2.
How many points intersect the x-axis? There are 2 of them, right? There's a point right here. By the way, what is that point that they're telling you? Negative 1.732, comma, negative 0. That's interesting, isn't it? Negative 0. Who knew?
I guess I
All right.
I've been wrong this whole time.
How about over here? What do you get for a point there?
1.732.
Told you 0 is negative. I'm kidding. I don't know why it's doing that. All right. But here's the deal on this, guys. I'm going to get rid of those points now. Hopefully I can. Oh, beautiful. I love it. What about this point down here? What do you think this is?
3.
Move that vertex down how many
Negative
units?
3.
So what's this going to be coordinate-wise? What, comma, what?
3.
Well, careful.
Negative
3.
0, comma, negative 3. Okay? All right, so I'm going to screenshot this real quickly, and I'm going to talk about what's here, guys. We're going to start looking at a lot of parabolas today, talking about movements, and we're going to be looking at parabolas in a different form here a little bit, all right? But the big idea today is this. The big idea today is this. When we have parabolas, you're going to be asked to find some intercepts. Remember when we were graphing linear equation, we said, what's the y-intercept, and then do the slope? You guys remember that? We talked about, right? Slope-intercept form. Plot your y-intercept and then do your slope. Okay? Well, with quadratics, we're kind of looking at some different stuff right here. And what we're looking at doing today is the following. We're saying, hey, there's some points in here that we need to know. And the points that you're really going to need to know are going to be, whoops, can you move the books in the bottle out of the way here for me so that I can transmit to my little USB? There's 2 points which are on which axis here, guys? There are 2 points which the parabola intersect with the x-axis here, right? Okay, so these 2 points intersect which axis, I guess I should say? The x-axis, all right? What do you think we're going to call these points? I'm going to call it an X. What do you think INT stands for? It was a stat Brett Favre was probably most famous for. Interceptions, right? No, intercepts.
He didn't play for the Vikings.
Yeah, he did. He was still playing for the Packers when the traitor threw the interception in a New Orleans game, too. What a traitor. He Benedict Arnold me, and I don't like it. Ugh. Ugh. Packers. Got my blood boiling now.
I don't like the Packers.
That's good. At least we agree on something, John. Okay, what do you think we're going to call this point down here, guys, then?
Y-intercept.
That's the y-intercept. Isn't this the point where the graph crosses the y-axis right here? Okay, so we're kind of looking for a y-intercept. Okay. So what we're going to do today is this. We're going to see different forms of quadratics in the way they're written. We want to come up and have an idea of how to see what these graphs look like. But the characteristics we're really going to focus on today with the quadratics, because there's a ton of them, but the characteristics we're really going to focus on today is where are the x-intercepts at and where is the y-intercept at. Okay. So here's what I want to do. I'm going to go back to this here. I'm going to need your help in a second. What I want you guys to do on the back side of your notes is to kind of, all right, this is my whole sheet of paper. Maybe we go like this. Maybe about a third of the way down, draw a horizontal line all the way across. And then split that bottom 2/3 like that. Okay?
All the way down.
Yeah, just, I guess, if this was my sheet of paper right here, on the back that you have, I would go like this. Okay? Make sense? All right. So at the top of this right here, here's what I want you to do. And this is also defined on the front side of your notes. If you'll take a look at the front side of your note page there, guys. Is this all your stuff? Yeah, it is. I'm sorry. Take a look at the front side. First key term in there. What's it say?
X-intercept.
It says an x-intercept and it says a
Y-intercept.
y-intercept. Notice the illustration right next to the x-intercept and y-intercept in key terms. Isn't that exactly the drawing we just looked at up there?
Yeah.
Find x-intercepts and find y-intercepts. It is, isn't it? So right up top here, here's what I want you to do. I want you to say, just draw a graph, kind of like I am. Make a parabola as best you can, about like I have. Okay. Parabolas. Gotta love parabolas. Wouldn't have cell phones without parabolas. Wouldn't have Dish Network or DirecTV without parabolas. Wouldn't be able to drive in the dark without parabolas. Wouldn't be able to. Maybe we should call our school the Union Fighting Parabolas because they're so important, right?
It sounds pretty cool. Sounds like a bird.
We can make our Union U in the shape of a parabola for our logo.
Could be.
Yes?
No.
Yes?
No.
And then when it says knights, we can make the end part of knights be an arch of a parabola. We could have parabola font. Well, I like it, don't you? No?
Is there a fun?
Wait a minute. Are you guys having flashbacks to me being in the nerd herd right now?
No, I'm.
Mariah's shaking her head. Yeah. Even though she's not shaking her head, I know she's thinking it. She's like, Carson, come on. Okay. Guys, what are these points right here called again? I'm going to put right here. What's this point called and this point in purple? The x-intercepts. All right, so I'm just going to put an x with a subscript of I right next to it, meaning the x-intercept. X with a small subscript of I. How about my point in green right here? What's this called? Again, the y-intercept. Okay. Okay, this is where things get kind of goofy for us today. I want you to understand something. We're going to kind of go out of order in terms of stuff, the way we look at it. But I'm going to jump back over into decimals, and I want you guys to understand what's going on here. All right. I'm going to type in a new function. You might want to do the same next to me. Okay. Let's just go something like this. Now, the format that I give you is going to be very different than what you've seen. But the format that I give you, I want you to understand that it's still some kind of a parabola. All right? You're going to start having two parts to this right here. Guys, if I asked you the question, if I said you had an x times an x, x to the first times x to the first is really x to what power? Second. Okay? So we're going to look at this in a different form, and I'll talk this idea that we just talked about here. But suppose you have something like x plus 4 in parentheses. And then here you have something like x minus, oh, I don't know, 2. You guys agree we have a parabola there? Okay. First question is this. Do you see x squared up there in anything that I wrote? Number 1. You don't, do you? Okay. However, what I have up here are two binomials, or two sets of parentheses. I have an x plus 4 and I have an x minus 2. Now guys, in between these parentheses, what operation is pretty much indicated right here?
Time.
Multiplication. So what I really have to do, guys, is I really got to bring in x times x. And this is something we'll talk about down the road, but what's x times x going to get you? That's where that idea of x to the second power is coming into play. So if I have any x to the second power into play, what kind of graph am I getting right here? Still a parabola, okay? What's our job today then? Find out the x-intercept and the y-intercept. Now the graphs are great. They tell us that already. If I look right here, what is the x-intercept right there? Negative 4. And what's another x-intercept right here? 2. Guys, how does the negative 4 and the positive 2 relate to what's up here? And I should really do something up here quickly. I should type it in as y equals. Oh, there. Okay. What do you notice about this right here, guys?
It's in the parentheses, it's got a positive. It's
Okay. The x value is what value here, guys? Negative 4. What's the y value here? Okay. What's the y value right here in this point? 0. What's the x value?
2.
Looks like to me to find the x-intercepts with negative 4 and 2, the y value has to be what value each time?
0.
0. That's exactly what we're doing here. Okay. The note I would make right here is the following. Okay. I notice that, hey, one of the intercepts is negative 4 comma 0. That means that when x is negative 4, if you plug negative 4 in here, what is negative 4 plus 4? 0. So 0 times something, going to make a y value of what? Going to make a y value of what? What is the y value on these x-intercepts, guys? 0. So I think that what we need to write down here in our notes, or on our cheat sheet part, is the following. How to find x-intercepts, how to find y-intercepts. So here's what we're going to do, the first part. We're going to figure out how did they come up with those x-intercepts. So I'm going to write down here how to find Is it okay if I abbreviate x dash int?
Yeah.
Okay. How to find x-intercepts. All right, here's the rule. Here is the rule. You're going to set y equal to, I'm going to go back to this right here, guys. In this function right here, what is the y value at the x-intercept? What do we have in each case?
0.
Zeros in the end of them, right? So we're going to set y equal to what value?
0.
0 and solve for x. Okay, so that'll be our rule. We're going to set y equal to 0. Then you want to solve for what? Okay, so in the example we're looking at on decimals right here, I believe I had y equals, was it x plus 4 times x minus 2? Was that right, guys? You guys agree with that? Now graphically again, what were my intercepts? Negative 4 and positive 2. So I want to know what this looks like without having the graph stuff. Well, here's how you do this. What's the rule say to do, guys?
Set y to 0, then solve for x.
So I have 0 is equal to x plus 4. Whoops, messed that up. X plus 4, that quantity times x minus 2. All agree?
Yes.
Give me some sort of sign that I know that you're where I'm at right now. Getting this down, we're all caught up.
I know mine isn't there, but
Anybody need more time getting that down before I move here? All right, I'll wait for you, Hannah. Give me a chance to get a quick drink of coffee.
we're in a group chat. Don't look. I wanna listen to your dumb side.
You guys want to take a walk?
What?
Want to take a walk?
No.
Please? All right, so here's the deal. This goes back to something we talked about last chapter, zero product. And basically saying you've got one quantity times another quantity that has to equal what value? 0. So what you're going to end up doing is splitting these two parts right here. And we're going to set both parts equal to what?
0.
So let's do this. I'm going to set x plus 4 equal to 0. I'm going to set x minus 2 equal to 0. Help me out, kiddos. On the left side, where x plus 4 is equal to 0, what steps would you take to get your x value all alone?
Subtract.
Subtract how much, Haley?
4.
4. Subtract that 4. What have you got as a value?
0.
0.
Careful.
I mean negative. I mean
Subtract
1.
Subtract 4 from 0. It'd be
Oh,
negative.
Negative.
Negative what?
4.
4.
I think it meant equal 4.
That's solved, right? Holy smokes, guys. Check this out. What was one of the x-intercepts again? Negative 4, comma, 0. Isn't that what we just found right here? Gosh, on the second part, how am I going to solve that x minus 2 equals 0? What's your steps? Add 2. And my solution for x will be what? Jeepers. Are you really serious about that?
Yes, I
Check it out.
am.
Wasn't 2 the other x-intercept?
Yes.
All right. So, looks like to me how to find the x-intercepts. Your rule, set your y equal to what?
0.
And then solve for what?
X.
What you get in the end for your x values will tell you my x-intercepts lie at that point. Now we said there were points, there were x-intercepts that we're looking for, but we also said we want to find a y-intercept. Quick question. If this is a rule for finding x-intercepts, do any of you maybe have an idea what the rule might be for this question? Hold on, let me write her down. Who's got that thought? John, you got? Hold that thought. Let me write this down. Anybody have thoughts on how to find, say, a y-intercept? John, what's your thoughts?
Set x to 0 and solve for y.
Excellent. Set x to 0. Why would you set x to 0? Well, check it out. Guys, down here, isn't this the y-intercept right down here that I just highlighted? Isn't that the y-intercept? What's the x value in that point? 0. So set x equal to 0 and solve for what? Y. According to this graph, what should we end up with? Negative 8, right? Okay, so let's check it out. Let's see if the rule holds. So we're saying, run it by me one more time, John. What's the rule?
Set x to 0, solve for y.
Set x equal to 0 and solve for y. Okay, let's try it. The original function that we're graphing right now, y equals, it was x minus, x plus 4 times x plus 2. Is that correct, guys? No, x minus 2, right? Do I have that correct, Mrs. Miller?
Yes.
Okay. What are we looking for here on the right side?
Make it 0.
What's that?
I didn't say anything.
Oh,
What?
what?
What did you ask?
So what are we trying to find?
Y.
Y-intercept, so we're going to set,
X to 0.
how many x's are there? 2. Okay, so let's do this. Y equals, in parentheses, what plus what to begin with?
0 plus 4.
0 plus 4 times. Okay, so this is y equals 4 times what? What is 0 minus 2 there?
2.
What kind of 2, kiddos?
Negative.
There you go. How about that product right there? 4 times negative 2.
Negative 8.
Sweet. Y equals negative 8. Y equals negative 8. Holy cow. Thank you. If I go back to my graph, isn't negative 8 what we ended up with here?
Yep.
Guys, the big idea today is this. We're looking for x and y intercepts of parabolas when we have products of binomials. Sounds like a lot of wordiness, right? It's not too difficult. You're gonna see functions written in different forms, or quadratics or parabolas written in different forms today. Didn't we already prove with our calculator you're still gonna get a U shape? Didn't we say, okay, to find the y-intercept you set x equal to 0 and solve for y?
Yep.
Other part of that would be then to find the x-intercept, set y equal to
0.
and solve for? Yeah. Okay, so let's do this. Let's do this. In your notes that you have, first of all, do you guys have this down on a cheat sheet part of your notes right now? This is kind of a summary of everything that's in there right now. I think we should look at some examples and confirm some things to make sure we're comfortable with this. Give me a show of hands right now. How many of you say, yeah, I think that this pretty much makes sense? Okay, the big idea today. Intercepts for quadratics. Set one variable equal to 0, solve for the other. Okay, so let's do this. In your notes, 10.3. Can I look at yours real quickly, Haley?
Yeah.
Yeah, I'm going to take that as a yes. Guys, what I'd like to do is to start with sample 1 right at the very bottom of your front side of the notes. So in sample 1, I need someone to read what's happening right there.
Graph y equals, in parentheses, x minus 2, and then in parentheses, x plus 1.
Okay.
The x and
Yeah,
y.
John, you're saying that's an already down.
Y equals x.
Minus 2. And then another one is x plus 1.
Okay. I think one thing I want to show you is this. I asked you to graph it. I'm going to say on your graphs, you do have graph paper. Now, guys, one thing I don't want you to lose sight of is this. We've talked about quadratics or a parabola being a U shape, but it can also be not a U sometimes, but an arch. Okay. Maybe the one note I want you to put down by sample 1 is the following. If you have a positive x squared somewhere, you will always get a U shape. Okay. What did the negative sign in the last section? What was its effect on quadratics when you threw a negative sign out in front? Flipped it, right? Okay. So if you have any kind of negative x squared, you know you're going to have what type of a shape then?
Arch.
Okay, St. Louis's finest.
I've done there.
Did you guys know that the function form of the St. Louis arch is negative x squared? Negative x squared, the flip, right? And then plus 630. Move that vertex up how many feet in the air?
630.
630 feet. Have anybody ever been to the St. Louis arch before?
Me.
The sign right in there says the highest point right at the vertex, 630 feet. Okay?
Oh.
I have a picture of that with me in there somewhere. In fact, I have a shirt that says St. Louis arch, negative x squared plus 630. Should have worn that today, right? What's that?
Haley, can you please?
Oh, I don't think you can get through those windows. That's a tough window.
And then my sister and my brother wanted to know.
Really? Those little
I need
pods that they put you in, those are kind of spooky, I think. Did you guys hear about the news years ago, maybe 4 or 5 years ago? one of the trains got stuck in there, and they were stuck in the arch for like hours in a pod.
I would pass out.
That's here nor there. Guys, quick question. On this right here, how do I know if I'm going to have an arch or a U shape? How do I know if I have an arch or a U shape?
Negative.
Well, you may or may not know, but here's how this is going to go. What I would always do is look at your x's. Look at the x times the x right here, guys. You got a positive x and a positive x, don't you?
Positive.
Won't that be a positive x squared when you multiply them together? So what kind of shape does this have to be before I even start?
Positive.
It's a positive. So is it a U or an arch? It's going to be a U shape. Okay. The whole idea today was to find the x's, find the y's, plot those points, and give me a sketch of the graph. This is what we're looking at doing on sample 1. You might just want to jot this down at the side underneath sample 1. Here we go. Let's find the x-intercepts first. All right. Volunteer to tell me how to start. Volunteer to tell me how to start. Change y to 0. Okay, so I've got 0 equals x minus 2 times x plus 1. Basically, how many parts do I have equal to 0? So what do I have to do with the 2 parts? Split them and set them both equal to what value? What's my solution in this first one?
2.
2. What's my solution in the second one?
Negative 1.
Negative 1. So if I'm making a sketch of a graph, put it right here. One of the x-intercepts is positive what here, guys?
2.
You guys agree with my point there?
Yes.
What's the second point? What's the second x-intercept?
Negative 1.
Okay, that would be left one, right? You guys agree I have those 2 points right there for x-intercepts now? Problems there at all? That's pretty easy, wasn't it? Okay, I'll do the y-intercept in red. Make some room here. We'll do the y-intercept. Okay, so what's the rule here, guys, for y-intercept?
Change the x to 0.
So come back up into here. X's are 0, so I'm going to have y equals 0 minus 2 times 0 plus 1. Okay, so this is a product of what and what? Negative 2 times positive 1. Very good. And what is that product? Negative 2. So my y-intercept would be what value, guys? So on the y-axis, you're going down how many units? Holy smokes, guys. Those 3 points that I have, the x-intercepts and the y-intercept, does that indicate that the graph might look like a U-shape or an arch? Looks like a U-shape. Didn't we confirm that when we took the x times the x and said, hey, that's a positive x squared, therefore it must be a what? Must be a U-shape, right? The Union Fighting Parabola logo. Yeah, the Fighting Parabolas, I like it. What do you want to be called? The Fighting Lines? Or the Fighting Rays?
No, for the knights.
How about the Paralyzing Parabolas? The Punishing Parabolas. I like it. Powerful parabolas. See? The powerful punishers.
That Parabola Panthers.
The power of the parabola. Anyways, let's focus on what a sketch would look like. There's a quick sketch. Again, what points are you basically looking for today, guys? X and y-intercepts. If I, part of the assignment, say, hey, find me the x-intercepts and y-intercepts, can you do it?
Yes.
Can I furthermore say, hey, I need to make a sketch or a graph? The idea is I need to find the x and y-intercepts, plot them, and then be able to sketch a graph. Can you handle that part?
Yes.
Okay. I think if you read through stuff, a lot of what we've covered already today, chillax, all right? I think a lot of what we covered here today, you should be in pretty good shape. One example I kind of want to hit real quickly, if you go to your third page, you've got some room at the bottom of the third page, right, of your notes. You've got some room there. One example I'd really like to talk about, it's kind of goofy, but I think you'll understand it. Just call this a be careful example, okay? One thing that can happen with this sometimes is the following. How many points have we gotten for intercepts? How many x's have we had? 2. 2, and how many y-intercepts have we had? 1. So typically how many points total? 3. Okay? May not always be the case. And an example on something where I'm saying be careful would be something like this. What if they throw out something like this here for us? Let's do this. Oh, let's just go 6 minus x. What the heck? That'd be a good one. I'm going to type this in. First of all, guys, what kind of x here on the left? Positive or negative? What kind of x over here in parentheses? What's a positive x times a negative x going to be in terms of exponents? Negative x to the arch or U shape? Arch. Going to be an arch. I'm going to confirm this quickly. So you guys remind me what that function was again. Y equals what?
X.
Okay. Y equals x. Whoops. Have we confirmed an arch? By this right here, what's the x-intercept? 0 and what? 6. What's the y-intercept? Where's the y-intercept? Where does it intersect the y-axis also? How many points is it, or how many times is this point being accounted for? Twice, isn't it? One time it's an x-intercept, another time it is a y-intercept. Let me show you how this works when we're going through this algebraically. All agree with the graph, first of all? Okay, and again, understand that decimals, I'm not saying type it in, get an answer. I'm saying get an answer, use decimals to confirm what you've done. Okay, understand the difference there?
Yes.
All right. Let's find the x-intercepts first. You guys agree for the x-intercept, y's got to be what? 0 is going to equal x times 6 minus x. Here comes your split. One part, x, got to equal 0. Second part, 6 minus, this is really minus 1x, isn't it, gang? Got to equal 0. That was pretty simple, isn't it? That was pretty simple, isn't it? If I saw that, x has just got to be what value? X has got to be what value? 0. Okay, one of them is just x equals 0. All right. So 1 x-intercept, 0. Help me solve this one. What would you have to subtract from both sides first? Okay, so you would have negative 1x equals negative 6, wouldn't you?
Right.
So to get that x solved for, you got to divide both sides by negative 1, right? So at this point, what's the negative 6 divided by negative 1 getting you? Or negative divided by negative. Positive, right? Right? Okay, so positive 6. So my x-intercepts are 0 and what? Help me out, gang. We're almost done. 0 and what? Stay with me. 0 and 6. Okay. Have I confirmed that graphically up here?
Yeah.
All right. Then, y-intercept part. Y-intercept part. Set x equal to what?
0.
Okay. Agree? Yep. This is really y equals 0 times 6, isn't it? Which is what value? Okay, now again, if I didn't have decimals, I didn't have the advantage of looking at it. The only points you would plot would be a 0 for the x, and then 1, 2, 3, 4, 5, 6. All right, but then when I plot the y-intercept again, I end up plotting the y-intercept right here. Really, how many times did that point get accounted for? Twice. The problem that I have here is what shape do I put through that, an arch or a U shape? Well, we know enough right here that if I take an x times a negative x, this would be some kind of a negative x squared, right? Which indicates to me that this must be an arch to the 2 points, okay? So the y-intercept is 0, and the x-intercepts are this. You understand why I say be careful there? Typically we've had 3 points. There truly are 3 points here, but one of them gets accounted for how many times? 2 times. Okay. Guys, what questions have you got? Just as a reminder, test, retakes, chapter 9 has to be done by Monday. The book page that I gave you, 565, that is due on Monday. Don't do the back side. Okay, there's a back side of it that says 635. Just do the page 565 part, okay? Hannah, question. Due on Monday. Okay, bring it to me Tuesday then. Or if you get it done early, bring it tomorrow. Sound good? Any other questions for me? All right, you guys have a wonderful day.